Swayam Prabha. Digital India. Educated India.
So, we will continue with the numerical part. So, this we have already discussed, where if we want to reduce it to 1/4 of the existing error, so we have to multiply the present number of readings with the square of 4, that is 16. Similar numerical is there, and this is valid for both 95% and 99% confidence level. Now, next problem, it's a similar problem is there. Here 76 is the present number of sample, 76, and 50 NE is the yarn count, and count CB is 2%. So, how many leads must be tested to in order to reduce the error percent of both count and standard deviation of count to 1/3 of the present error at 99% level. So, as we have seen earlier case, so 99% and 95% means same, because the number of sample we have to take to reduce the error at a certain level. So, 99% and 95% level is same number. So, here what we have to do? We have to test for both count and standard deviation. Error in reduce the error percent in both count and standard. So, let us do one by one. So, CB percent is given. So, CB is not going to be used in this calculation. We need standard deviation. So, standard deviation by mean is here 50, because CB of count is there. So, mean of count into 100 is 2%. So, from there we can calculate the standard deviation. Okay. So, what is the standard deviation here? Standard deviation will be hundred, 2 multiplied by 51, so it will be 1. Standard deviation is 1, and if we go on calculating the things, will, as we have done earlier case for mean, we will get the value. The 76 was the present number multiplied by 3 square. So, 1/3, 76 multiplied by 9. The number of readings will be 684. Without any calculation, we can do it. and this will be valid for both count and standard deviation. So earlier we have done for yarn count. Now let us try for standard deviation. So present standard deviation is 1. So for calculating t value, so standard error of standard deviation will be 1 by under root 2 into 76, because 1 is the standard deviation. So standard error of standard deviation will be 0.006, standard error of standard deviation. So t will be standard deviation, so that we can have certain standard deviation here. So count, so earlier problem was that here you can see here, for same standard deviation, so standard error t value is here, so t multiplied by standard error, 0.08, sorry, this will become 0.08. Okay. Now using the similar treatment here for standard deviation, so 1.96 was the t value, okay, at 95% level. So 99% level it will be, so t value will be 2.5458 t multiplied by standard error. Initial standard error was standard deviation by under root 2 multiplied by n 1. This is the error 1, and our next error will be the 1/3 of this. So new error is 2.58 divided by standard error of standard deviation. So standard deviation by under root 2 n2. Okay. So this is the relationship. So all these things will will be eliminated. So what we will have, 3 by under root 2 n2 equal to 1 by under root 2 n1. So this is the relationship which we are getting here. So N1 is 76. So 3 by under root 2 into equal to 1 by under root 2 N1. So from here we can get it that you square it in the both side, 9 by 2 N2 equal to 1 by 2 N1. So 2 cancelled out. So N2 will be equal to 9 multiplied by N1. So that is, it's giving the same number. So it means whether it's a count or standard deviation, whether it's 99% level or 95% level, the strategy should be, if we want to reduce to a certain level, we have to multiply by the square of that level. Okay, here it's a 9, 1/3. So 3 times reduction, that means square of 3. Now next numerical is that a sample of 163 ring bobbins is selected from a population of 1 million bobbins. So we have selected 163 ring bobbins of nominal count 40 English count, and this is selected to test the standard deviation of yarn count. So 163 bobbins are selected. The confidence interval of the standard deviation of yarn count at 99% confidence level is found to be 2.4 and 3.6. So confidence interval here means here so at 99% level, large sample we have taken, the 99% level, t value is 2.58 multiplied by standard of error. Okay, and here also confidence interval of mean, so standard error of mean, this is minus 2.58 2.58 multiplied by AC of m, this is minus. So this is the range, and what is this? This is 3.6, this value is 3.6 and this value is 2.4, and x bar is the mean value. So x bar minus 2.58 multiplied by standard error is 2.4. X bar plus 2.58 into standard error is 3.6. which is given here. Now, what is the confidence interval of mean of yarn count at 95% confidence level if 50 more ring bobbins are added to this time with the earlier sample during testing of mean yarn count. So, earlier sample was 163, this time it will become 163 plus 50. So, for that we want to calculate the confidence interval at 95% level. So, new number is given, new level is 95% level. But here one thing is that this mean is not going to change. Mean is not going to change. So, the confidence interval of standard deviation is given. So, confidence interval of standard deviation is given, but confidence interval of mean of yarn count is being asked. Okay, and the calculated mean of yarn count is found to be 39. So, here mean count is 39 and so this is for mean, and for standard deviation let us draw again a new, this is for standard deviation. Here it's directly it's given. So, what we have done, it was little bit wrong. This is let us consider it's a mean for mean. Okay, this is for mean, and here it's the value which is given, it's for standard deviation. So, plus 2.58 multiplied by standard error of standard deviation, so x bar plus, so this value is 3.6, here it will be 2.4. Now, if you want to calculate the standard deviation, so standard deviation will be at the midpoint of this. So, standard deviation of the sample, that standard deviation confidence level will be, so standard deviation of the population will be, say this is the confidence limit. So, the mean of this two value will be the standard deviation, that is the midpoint. So, 3.6 by plus 2.4 by 2 will be the mean standard deviation. It will be 3. 3 is the mean standard deviation. Okay. Now, so standard deviation of population is calculated here. From there, what we have to do, we can calculate the standard error of mean, and we can calculate the number of variety. So, here the solution is, the number of bobbins selected at present is 163, and the mean standard deviation as I have mentioned, so it is midpoint of this two intervals. So 3 is the standard deviation. So this standard deviation will be used to calculate the standard error of mean. So 50 more bobbins. So when we are considering, initially it was the standard calculated for standard deviation, but confidence interval of mean, which when we are trying to calculate at 95% level, by that time we have added 50 more bobbins. So here the number, effectively the number of bobbins are 213. So n becomes 213. So confidence interval of mean yarn count at 90% confidence level will be 39 was the yarn count as it was given. Mean calculated count is 39. Thirty-nine is the calculated count. So it will be at 95% level, it will be 39 plus minus T into standard error of mean. That is the confidence level, confidence level. So if we calculate, so n becomes 213 and standard deviation we have already calculated 3 mean standard deviation. So this is becoming 39 plus minus 4.402. So the confidence interval of mean yarn count is becoming 38.598 and 39.402. Now what does it mean? So our mean count which we have got, it's 39, but we don't know about the, we have taken the sample of only 213 bobbin we have taken, and we have done the statistical analysis. We have measured the mean, standard deviation, standard error, and from that level we can actually, we can tell with a 95% confidence that our number of the, at with a 95% confidence that the mean value of the population will range between 38.598 to 39.405. That is the, within that range we can tell with a 95% confidence level. So this is the range on within which our, if we test the mean of the population, that will lie within this, and 95 times it will be correct, that, and 5 times it may be within, beyond this level. Now if we want to be more sure, suppose we want to test at 99% confidence level. Let us see 99, at 99% confidence level, keeping all other parameters same. So the confidence range will be 39 plus minus, in place of 1.96 it will be 2.58 into 3 by under root 213. 39 plus minus, so this parameter is going to be 0.53, which means that 39 point at 99% level, what we have got, it's a 39 plus minus 0.53, that means it will become 39.53, and in this side it will be 38.47. So the range has been increased, it is 99% level, and this will become 95% level. So if we want to be very sure, more accurate, so in that case our confidence interval is little bit more. So within that, that means the data, the population mean will lie within this zone, and at 99% time it will be correct. Okay. Now coming to another aspect of judging that the variability of material, which is actually, it's by diagram we can see, it's a pictorial representation of the variability of material, which is known as control chart, which is a convenient method of presenting routine test data in a readily understandable form. So analyzing and calculating the data, t-test and all this are important for in-depth analysis, but for day-to-day understanding of the variability, the control chart plays an important role. So where this is the initial chart which is created based on our previous experience. So previous experience is what? So we know from our experience what should be the standard deviation. Standard deviation, this standard deviation sigma is obtained based on our previous data, either previous data or the data given by our customer, that if they want, okay, we need this much standard deviation. So some data standard deviation will be imposed on the during the production, or we, based on our previous experience, we can form. And this is the control chart, which is a blank control chart is formed. Typically a control chart is this is kept for, the data is kept for 1 month. Okay, so date wise we can give for different date 5, 6, 7. So at different date, and what we are giving here, the information is, its mean is our target value. Suppose we want to produce, we are producing say 40 any yarn throughout the month in a particular machine. For a particular machine we are producing 40 yarn count, so 40 is the yarn count, and plus 2 sigma, plus minus 2 sigma limit, which is called warning limit. So plus 2 sigma is upper warning limit and minus 2 sigma is lower warning limit. So what is warning limit? If the data is within this warning limit, that means the system is going all right. But once it is, the data is going beyond this limit, we should not stop our activity, but we should give the warning to the production section that something is wrong there. One should try to adjust the machine and then bring the count within that limit. Like 40 is the count, so let us consider that the nominal standard deviation, say it's a 0.5, so or acceptable standard deviation, so plus 2 sigma limit, it will be 41, and here it will be 39. So 39, between 39 and 41, if our reading comes, data comes, it's okay. But if once it is crossing, and suppose it's a 0.5, so 41.5 and 38.5, so within that zone. But so if it is beyond 41 and less than 41.5, so between 41 and 41.5, if it is ranging, or on the other hand, in the coarser side, if it is between 38.5 and 39, then we should give the warning to the department that one should take precaution, but without stopping the machine. Let the production go, but the warning should go that there something is wrong happening. But once it is crossing the upper limit, upper action limit or lower action limit, so when the count is finer than 41.5 or even coarser than 38.5, then we must stop we should take action. So once it is finer than 41.5, then we stop the machine, we readjust the draft, we can reduce the draft level, and we can bring it to within the acceptable limit. So this is the concept here. Now, so say 41.5, 40 count we have, this is our blank control chart, and what we are doing, so 40 is the mean, and we know the 41, 39 and 41.5 and 38.5. Now day 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and in a order. So 40's count is producing in a ring frame for 1 month. So in first day 1, you have got this value here, mean value, so we are putting this. So in this way we will keep on so this way it will give you the clear picture without any calculation, the performance of a machine, how many time it is crossing the limit. Suppose a particular machine, it is showing always in the finer side. Always the count is in the finer side, between say 40 to 41. Continuously it is showing the count between 40 to 41 continuously. So although it is within the warning limit, we are only giving warning. It's not crossing even, we are not giving warning, but still there is some issue. So this machine is, so after 1 month, after analyzing this control chart, we can, when the maintenance, it's going for maintenance, we can readjust the count, but during the production we are not disturbing. But this control chart gives one overall understandable form. It's a understandable picture, so that you can get overall idea what is happening in the production. So control limits are chosen on the basis of experience or previous trend. So this control limit means this standard deviation. So based on experience or previous trend, if the data fall outside the warning limit, no immediate action is taken. We should not stop the machine, but we should give warning. So this is the type of control chart, days in a month in x-axis, and here it's a mean yarn count. So majority of the days, it will see that this the count value is within the warning limit, but in few days these are crossing the warning limit, but in one day it crossed the action limit, where we had to stop the machine, and again after readjustment the count has come back to the acceptable limit. So this is the picture. It is showing that throughout the month what happened. Okay, this is not possible by calculation. But if we calculate, if we make table, then we have to analyze in detail. It will take time. This will give the instant information.